Okay, good evening. Welcome to MathForKids53. This will be the last in our continued fraction video series. Is that yay continued fractions, or yay video, or yay last continued fraction video?
Last continued fraction video!
Yay! Okay. Just get over. So, we're going to talk about today kind of a fun, easy way to evaluate continued fractions instead of having to go through every single time and evaluate, okay?
Yeah.
This only works for a special kind of continued fraction where it's like something plus 1 over something plus 1 over something plus 1 over. Okay, it only works for that, but it's still pretty useful.
The 1 overs.
The 1 overs. The 1 over kinds of continued fractions. So let's look at that really simple one we were looking at the other day. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over. And when we looked at the first couple of terms, remember we called it x0 was when we just looked at the first term, that was 1. x1 was when we looked at the first two terms, and that was 2. 1 plus 1 over 1. Remember that?
Yep.
x3 was when we looked at the first three terms, so this was 1 plus 1 over 1 plus 1 over 1, which is 1 plus 1 over a half, which is 1 plus 3 halves, which is 1 plus 2 thirds, which is 5 thirds. Is that right? Did we make a mistake? That doesn't feel right.
Seems not right.
Okay. Well, let's see. 1 plus 1 over... That's definitely 2, and the next one's 1 plus 1 over 1. Oh, which is 1 plus a half. See, I knew that was wrong. 1 plus a half. So it's 3 halves. There we go. That makes more sense.
Yeah.
Sorry about that. Happens when you don't know what you're going to talk about 5 minutes before we decide to do a movie. 1 plus 1 over 1 plus 1 over. Okay. So we have this kind of pattern. Now we're going to learn a special way to look at this, and it involves looking at these terms only, so not the 1 overs, just those terms. And we're going to write them out. Okay? We're going to write them out in a little special continued fraction machine. Ready? And here's what our continued fraction machine looks like. First we write those special numbers. In this case they're all 1s, right? Okay. And then we start over here with a machine that just has a 0 and a 1, and a 1 and a 0. Alright, now this is a special procedure. It'll get you a little bit of arithmetic practice, and then we'll look at some other more complicated continued fractions, okay? You ready?
Yep.
Okay, so all you do is you take the term up here, multiply by the box that's 1 below it and 1 over, and add what's in this box. Okay, so 1 times 1 is?
1.
Plus 0 is?
1.
Okay, and then you do the same thing down below. 1 times 0 is?
0.
Plus 1 is?
1.
Okay, so we get 1 over 1. 1 times 1 is?
Is 1.
Plus 1 is?
2.
1 times 1 is?
1.
Plus 0 is?
1.
1 times 2 is?
2.
Plus 1 is?
3.
1 times 1 is?
1 times 1 is 1.
Plus 1 is?
2.
Okay, now you show me what goes into this box.
I see something.
What do you see?
That the numbers on the bottom are always 1 behind the numbers on the top.
Oh, interesting. Well, let's see if that pattern continues.
Okay, so 1 times 2 is 3. Plus 2 is 5.
Awesome. Okay, what about what goes down there?
1 times 2 is 2. Plus 1 is 3.
Okay, so did your pattern continue?
No.
Okay. Alright, you notice anything else about the top and bottom numbers? Yeah?
Well, the bottom is always smaller than the top.
Okay, that's a good thing to notice.
So 1 times 5 is 5. Plus 2 is 8.
Okay.
This looks like the Fibonacci.
Interesting.
1, 1, 2, 3, 5, 8. This one might be 13.
Ooh, okay. What about on the bottom?
1 times 3 is 3. Plus 2 is 5. There's Fibonacci numbers in both 1, 1, 2, 3, 5.
Huh, okay, well let's go one more if there's room on the camera. Let's see.
Yeah.
Oh yeah, actually you know what, there's room for two more. Okay, so I got a 1 and a 1. So what goes next? 1 times 8 plus 5?
1 times 8 is 8 plus 5 is 13. Yes. 1 times 5 is 5 plus 3 is 8.
Okay.
1 times 13 is 13 plus 8 is 21. 1 times 8 is 8 plus 5. 8 plus 5 is 13.
Okay, so this is this continued fraction machine, as long as I could show to you that this actually works and gets the right answers, but these are what we were getting before, right? I mean, you remember we were getting the Fibonacci number?
Yeah.
So it actually, is a pretty easy way to evaluate these special kind of continued fractions. And on top of that, you get some really interesting properties that you can learn about the continued fraction. So this is 1 over 1, 2 over 1, 3 over 2, 5 thirds, 8 fifths, 13 eighths, and 21 thirteenths. Okay.
Yep.
Now we're gonna see some special stuff about these fractions, which are called the convergence of the continued fraction. Now this is where math can get really, really fun. What if we just do some multiplying? What if we multiply these two numbers and those two numbers? We get 2 and 1. Okay? Well, that doesn't seem all that special. 2 and 1. What if we multiply these numbers and these numbers?
Box.
What do we get?
3 and 4.
3 and 4. Okay. 2, 1, 3, 4. That's it. Who knows? Maybe this will turn out to be interesting. What if we multiply these numbers?
Okay, we get 9 and 10. Okay,
so I've been writing the one going this way first, so I'll write it as 10 and 9.
Well, I do see something.
What?
That this number is always 1 larger than this.
Okay, so the first number is always 1 larger than the second?
No, you didn't write them.
3. Here I write 2 and 1. 2, 1. 3, 4. 3, 4. 10, 9. 10, 9. So I'm always writing the this way number first.
So that doesn't continue.
That pattern doesn't quite continue. But let's see if we can find some other patterns. 10, 9. So it looks like sometimes it's 1 larger, and sometimes
the one in front is smaller.
Well, okay, how much smaller?
It's 1 smaller.
1 smaller, interesting. So let's write them this way. 24, 25. Okay.
Hit that. It goes this.
Alright, so which one do you think is going to be bigger this time?
The one in the front.
Okay. 5 times 13 is?
50 plus 65.
65. 8 times 8 is?
64.
Hey.
Was bigger.
Okay, what about 21 times 8?
It's 100 plus 1 times 8 is 808.
How'd you get 100?
20 times 8 isn't 100. It's 20 times, it's 160, 168.
168. And 13 times 13, you remember what that is?
169.
How'd you know that?
I think 10 times 10 is 100 and 3 times 2 is not. 10 times 10 is 100. And 3, no, it's 169.
How do you know?
I just remember that.
You just remember, okay. How would you do that multiplication? You would do 10 times 13, which is 130,
130.
plus 39. 169. Okay, so we got actually an interesting pattern where you get plus 1, minus 1, plus 1, minus 1, plus 1. That's kind of neat.
Interesting.
You want to see if it works for another continued fraction?
Yeah.
All right, so let's just pick a continued fraction. Got to see how far our board goes down today. Sorry about that. So let's pick a continued fraction. How about just 1 plus 1 over 2 plus 1 over 1 plus 2 over 1 plus
Didn't
1
you say
over 2.
it doesn't work as well?
Oh, sorry, I didn't mean to put a 2 there. Jeez. I want to alternate 1s and 2s. 1, 2, 1, 2, 1, and then this would be 2. Okay, so just alternating 1s and 2s. Okay, so you ready to put this into our continued
Yep.
fraction machine? So it's going to go 1, 2, 1, 2, 1, 2. Okay, this could be fun, right?
Yeah.
Yeah. Okay, so let's put it into our continued fraction machine. Okay, so remember it starts out by going 0, 1, oops, yeah, that's right, 1, 0. And then going all the way over here like this, and then boom, 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 boom. Now if we were actually evaluating the fractions, it might be kind of tricky, but let's just do, did I start with a 1? Yeah, I did. 1, 2, 1, 2, 1, 2, 1, 2, 1. Let's see what happens. 1 times 1 is 1 plus 0 is 1. 1 times 0 is 0 plus 1 is 1. 2 times 1 plus 1 is?
It's 3.
3. 2 times 1 plus 0 is?
It's 2.
2. 1 times 3 plus 1 is?
4.
4. 1 times 2 plus 1 is?
3.
3.
It's interesting because
2 times, what?
because the number on the bottom is always 1 less than the number on the top.
Alright, well let's see if that continues. 2 times 4 is?
8.
Plus 3 is?
11.
2 times 3 is?
6.
Plus 2 is?
8. Didn't continue.
Didn't continue. Oh well. 1 times 11 is?
11.
Plus 4 is?
15.
15. 1 times 8 is?
8.
Plus 3 is?
It's 11.
11. Okay. 2 times 15
30.
plus 11?
Is 41.
41. 2 times 11
It's 22.
plus 8 is?
It's 30.
30. Okay, so we get kind of a neat little pattern. It's hard to know what's going to be next, but let's see if our multiplying pattern works.
A box multiplying.
3 times 1 is?
3.
1 times 2 is?
2.
Okay. 4 times 2 is?
8.
3 times 3 is?
6. That's it. 9. 9. The win.
11 times 3 is?
33.
4 times 8 is?
32. Looks like it's holding.
Looks like it's holding. 15 times 8. Ooh, that's a tricky one.
80 plus 40, 120.
120, okay. 120 and 11 times 11.
It's 121.
Whoa. Okay. Okay.
You would 11.
I wrote 11. Ah.
11 times 11 is not 11.
11 times 11 is definitely not 11, because 11 is not 1. Okay, now let's do this last one. 41 times 11. Ah! Eesh.
Well, that's 410 plus 41, 452, 451.
451. Very good. 15 times 30.
Whoa.
Whoa.
10 times 300 plus 150, 450.
450. Hey, look at that.
So it's holding.
It's holding. That's kind of neat. I wonder why we get this plus 1
Little
minus 1
box
pattern.
multiplying.
But it shows you a couple things, that continued fractions have really interesting properties. And it's not, so this next number over here is going to be some kind of really interesting special number. It can't just be anything. It can't be like 9 halves that comes next, because 9 times 30 is 270, and 2 times 41 is 82.
Well,
So
and
that wouldn't work.
it keeps getting larger.
Right, and they keep getting larger. So they actually have really interesting properties, and people worked out a lot of really fun properties about continued
Are there
fractions.
still being more found today?
What?
Are there still being more found today?
Yeah, I probably. There's a couple neat books about continued fractions, and they have lots and lots of neat properties. You can solve really special equations with them. You can find solutions to equations like x squared minus 17 times y squared equals 1. Whoa!
How in
So you can this is hard. It's hard to figure out like how you would solve an equation like that, but continued fractions help you, and you can do lots of other really neat things with them. Someday we'll learn a little more about continued fractions, but this was just kind of for fun practice with fractions, and I wanted to show you something really neat about fractions. All right, was this fun?
Yeah.
All right, cool.
We forgot to close the door.
Oh, we did.